Welcome to Flip Lesson 116 for the 6th grade as we look today at compound interest. Now, interest is a concept that comes up a lot, often in banking, comes up in loans, and different things like that. And this is a concept that is really an important concept because it can really save you a lot of money or make you a lot of money depending on what's happening, whether you're trying to invest or whether you're taking out a loan. All right, and it's definitely applicable to lives because chances are you're going to have a bank account if you don't already, and chances are you might have to take a loan someday in the future, maybe to go to college, maybe to buy a house, buy a car, different things like that. So let's get a basic understanding of what's going on. We start by looking at really what's called simple interest. First, we want to understand what simple interest is before we look at compound interest. For example, let's say you have a savings account and you put $100 into that savings account. Now, savings accounts, usually the point of the savings is if you put that money into the bank, they're going to give you a certain amount of interest every year that you keep that money in there. All right. And so, for example, we're going to say you have a 3% simple interest rate of $100 getting you through this bank. And so what does that mean? That means that at the end of the year, you should be able to take that $100 and multiply it by your 3%, which would be this idea. And you're going to come away with, of course, 3, which means that you gained an interest of $3. And simple interest means that every year, since you put $100 in, every year they're going to give you 3% of that original $100. And so the first year you're going to get $3 and you're going to have a total of $103. And then the next year you're going to get another $3 and you have a total of $106. And the next year you're going to get another $3 and you're going to have a total of $109. And so after 3 years of your money sitting in a bank, you will have gained $9 more for putting it into that savings account. Right? That's what simple interest is all about. Right? However, most people don't like simple interest. They want their money to grow faster. And that's where we get this idea of compound interest. And this is what a lot of banks will use, right, to get you to invest in their savings account because they say, here, we have compound interest on your money. So what does that mean? It literally means it's going to compound. It's going to repeat again and again and again. And so the first year, it's going to really look the same, all right? And all my smarts, I wrote the wrong number here. All right. Oh, it's grouped together. That's why. All right. So if I have that same interest, right? Okay, that same interest, right? $100 at 3% interest in a bank, but now my savings account has compound interest. What does that mean? That means after 1 year, right? We know that we're gaining $3 in the first year, and so at the end of the first year, you have $103. But this is where compound interest changes. Now, instead of going back to the original $100, compound interest is going to build off of what you literally have in the bank. So the second year, it's going to take that $103 that you had made the first year in that saving, and it's going to multiply it by that 3%. Right? And so you're going to probably want to pull out a nice calculator, right? Not that you can't do this math, but this is a good lesson to practice using your calculator, and it's okay to use a calculator on this lesson. The book is even going to encourage you to use a calculator, right? And in a minute, we're going to even talk about how to do different things on the calculator. And so if you solve this, what you're going to find out is that you will have earned $3.09 off of that $103. So now your total at the end of the year is $106, right? So it's this, the end of the original amount, plus your new interest, which gives you this amount. And of course, it's going to compound again. So if you start the next year, right, how much money are you going to have at the end of 3 years? Let me fix my numbers there, right? And so now we have this number times this number, and this is part of the reason why calculators can be really nice. It's not that you're not capable of doing this math. I could definitely say, all right, solve these problems together, right? But it's okay to start working with this, right? Now, technically, if you were to multiply this out, you would get a number like this on your calculator, right? But of course, we're dealing with money, so we got to understand what does that mean, right? And in the end, we're going to say, okay, that's our penny. We're going to look back to, okay, it's only $3.18 in terms of money, because banks don't want to give you that extra cent, right? Stores, they want to take that extra cent, that fraction of a cent, but banks, they're not going to give that to you, right? Or they don't want to give that to you, all right? And so we have $3.18, and so we're going to add that to our 106.09, and so in the end, after 3 years, your bank account is that much bigger. So in the end, what we see here is the difference between simple interest. Simple interest is going to give you a good amount of money. It's going to give you $9 extra at the end of those 3 years. But compound interest is actually going to give you 27 cents more. Now the question is, what would you rather have? Just $109? Or would you like $109.27? And of course, banks are going to use this to help them to get that interest, give you that interest, that savings, and it's going to make you feel like you're earning a lot more money. Okay? Now, of course, this can really follow a number of different processes then. And as we look at this concept, what we want to see is that there's some shortcuts that we can take. All right, a calculator is definitely going to help us understand these concepts. It's going to help us get through these. But there are just some simple math concepts that we can use to help us understand how to build that interest, right? How to build that compound interest. So our example says Mrs. Farquad opened a $2,000 retirement account that has grown at a rate of 10% a year for 3 years, right? So now it doesn't say compound interest right away, but that we got to look at the clues in this word problem to help us understand that is it a simple rate or is it a compound rate, all right? And it says that it's grown at a rate of 10%, right, for 3 years. And this is showing us that it is really increasing. This is a compound interest type problem. So saying how much, right, after 3 years, what is the current value of this, right? Now we could take this, 2,000, and we could multiply by 0.1. Now I'm putting zeros. 0.1 for that 10%, right? And get 200. Is that right? Yeah. And we can add that on and go to this idea, right? Add it to there. But the fact is we can actually use a mathematical step to get to this number after our first multiplication. And what we do is we're going to take our initial amount, right? And yes, we're going to add in our percentage. But because we want to know, well, how much do I earn at the end of the first year, or how much do I save at the end of the first year, I can add a 1 in front of that. Now, what does that 1 mean, right? We know this 0.1 equals 10%. So what would this one mean? That, of course, would mean 100%. And what this new decimal is really saying is I want to keep that $2,000, right, that whole, that 100% that I already have, and I want to include that 10% additional that I'm going with this, right? So I can make it 1 standing for 100%. So I want to keep the 100% of this, but I also want to have this here, right? And if you look this over and you do the math, you're going to quickly realize that 2,000 times 1 1/10 is going to give you a fast answer of this, right? And so it's going to get you to the same steps. But now we can use this method again, right? Instead of going, okay, let's take this number times 0.1 and then doing some math, we can just jump right into this and say, okay, let's multiply by 1.1 again. And as we look at this, right, you could sit there and you could do the mental math, right? You could write this all out. This is definitely doable, but this is okay to pull out the calculator. All right, we want to start to get into habits of using calculators, right? Not to do the work for us, but to understand that, okay, we understand what we need to do. We've set up the problem correctly. Let's use it because we're going to start to get some big decimals, different things like that. And we get that, right? But the question says 3 years, so we actually got to do a third time. And so I'm going to throw that in there. And then I can multiply that real quickly on my calculator, just like you'll be able to multiply that on your calculator. And you work with that just like that. So in the end, you can see your interest has grown by that amount. So this is how much money she has now after those 3 years. So we have this concept so far, right? So we're taking these shortcuts, all right? Method 2. I wonder if I just showed you method 2 instead of doing method 1. All right, so I got ahead of myself. Basically, I'm showing you both methods at the same time, right? So this is method 1, right, where we take the percentage, we change it into a decimal, we multiply, we add, we start over, right, and do the addition. Method 2, which is what I was supposed to show you next time, right, is this right here, where we're multiplying by that 110%. To work with them together, where it adds everything up for you within the multiplication itself. All right, and so we have these two ideas so far. Now, the other cool trick that we can use, right? I'll just leave a quick note, right? So this is this idea, right? Method 2, right? Plus the percentage, the interest rate percentage. I'll give you that note to help you understand that. Right. The third idea really gets into the use of a calculator, right? Now, I've been telling you to use a calculator to solve some of these things, right? If you have one available, there's always one in a computer built in if you need to. But calculators have some really neat functions that enable you to do this actually a little bit faster, right? And it's called the memory function. It's what this button is right here, this M+ button. It's a memory function. So what I can do is, right, I got $2,000 in the bank. I'm going to do a 10% compound interest, right? And I want to know, right, I'm going to use my shortcut, my 110%, right, my 1.1 to get me to see the total interest much faster. So if I start by doing that 1.1, then I press the memory plus button, you can see that suddenly there's this little M up here in the top corner, and that stands that that number is put into the calculator's memory, right? And the more advanced calculator you have, the more menu you have, all right? The more options you have. The memory buttons, this is what it looks like in the school's calculators. If you have a different calculator at home, you may have to play around with it a little bit to figure out exactly what your memory button is. Your book shows a couple other examples of what memory buttons can look like. All right, so now we can do our problem though, right? I can say, okay, I'm going to take 2,000, right? And I can multiply, right? And this button here stands for memory recall. That's what MR stands for, memory recall. And then the C also means memory clear, and I'll show you what that means in just a minute. So if I press it one time, right, I can see that the 1.1 comes up. Press equal, right? So that's the first year. Memory recall. Second year. Memory recall. Third year. And it can work just like that, right? Technically, you don't even have to press the equal sign. Until you get to your final one, right? And then, just for calculator use sake, right, we see we got the same answers we've gotten in the last few times. Right, if you go to a new problem and you want to get rid of what you stored in the memory, basically you just got to start tapping this until your little M disappears, and then clear your calculator like that. Okay, that's enough talking on my part, right? It's time for you to work through this, right? If you got questions, don't be afraid to ask those questions in class. Here's your sample. You're going to make a comparison, right? You're going to see John is depositing $2,000 at 5% with simple interest, right? Go back to what simple interest is, compared to Carol, who's depositing a smaller amount with a higher interest rate, but hers is compound interest. So the question is, who makes more at the end of 10 years? All right, that is lesson 116.